In the rainforest, there exists a parasite so disturbing, so precise, that it can take control of another creature's mind. It doesn't kill its victims immediately. Instead, it puppeteers them, forcing them to climb, bite, and die exactly where the parasite wants. This is not a horror story. This is real biology. A fungus that hijacks insect brains, rewrites behavior, and uses living bodies as machines to spread its spores. For millions of years, insects and fungi have been locked in a deadly evolutionary war, and the battlefield is the mind itself. Welcome to the world of Ophiocordyceps, nature's true zombie parasite. Many people think zombies exist only in horror movies, but nature created its own version millions of years before humans appeared. And it's far more terrifying than fiction. Ophiocordyceps fungi have evolved the ability to hijack an insect's brain, rewrite its behavior, and use its body as a vehicle for reproduction. The insect is fully alive during the process, but no longer in control. To understand how this fungal parasite works, we have to start on the forest floor. Here, spores lie dormant, waiting for an unsuspecting host. When an insect, usually an ant, but sometimes a beetle, wasp, or caterpillar, passes nearby, the spores attach to its exoskeleton. Then the invasion begins. The fungus drills through the insect's outer shell using specialized enzymes. Once inside, it spreads through the hemolymph, the insect equivalent of blood. This is where the parasite begins its true attack. Ophiocordyceps doesn't just eat the insect. It infiltrates the nervous system, releasing chemicals that target specific neurons responsible for movement, decision-making, and survival instincts. At first, the insect appears normal. It continues its daily routine, unaware that something inside it is rewriting its destiny. Over time, the fungus spreads through the body like a slow-moving network. It grows fungal filaments that creep around muscles and latch onto organs. But the most important target is the brain. This is where the fungus becomes a puppeteer. Scientists have discovered that Ophiocordyceps releases compounds that alter the insect's brain activity. These chemicals disrupt neural signaling, turning natural instincts into obedient compliance. The insect no longer acts in its own best interest. It acts in the interest of the fungus. And the first command is simple: climb. Infected insects experience a sudden, overwhelming urge to leave their colony or habitat. Ants that normally stay low to the ground begin climbing vegetation. Caterpillars that stay hidden crawl upward toward exposed branches. This behavior, called summit disease, is triggered entirely by the fungus. The higher the insect climbs, the more advantageous it becomes for the parasite. Up high, humidity, airflow, and sunlight are perfect for fungal growth. But the fungus needs one last act from its host. Once the insect reaches the ideal height, the fungus orders it to bite down. This is known as the death grip. The insect clamps its jaws into a leaf or branch with unnatural force. Once it locks in, it can't let go. The fungus ensures this by weakening the insect's muscles and eliminating its ability to control its jaws. From that moment on, the insect is no longer alive in any meaningful way. The fungus consumes what remains. Inside the body, Ophiocordyceps digests the insect from the inside out. It preserves the external structure just long enough to use it as a support for something far more horrifying. Eventually, a long stalk bursts from the back of the insect's head. This is the fruiting body of the fungus. When it matures, it releases thousands of new spores into the air. Each spore becomes a potential new infection, and the cycle begins again. This gruesome strategy has been perfected through millions of years of evolution. Every step, the infiltration, the mind control, the climb, the death grip, is a precise adaptation designed for maximum survival and spread. But the war isn't one-sided. Insects have evolved defenses of their own. Some ant colonies can detect the subtle changes in behavior caused by fungal infection. When a worker ant starts acting strangely, its nestmates intervene. They isolate the infected ant or remove it from the colony to prevent the fungus from spreading. Some species even have burial behaviors, where infected ants are carried far away and dropped in isolated spots. Other insects groom themselves constantly to remove fungal spores before they can take hold. Some rely on beneficial microbes that inhibit fungal growth, Entire colonies participate in hygienic defense strategies, working together to prevent the deadly parasite from infiltrating their society. Ophiocordyceps and insects are locked in an evolutionary arms race. Each adaptation by the fungus forces insects to develop new defenses. Each new defense forces the fungus to evolve even more sophisticated strategies. This constant back and forth has created one of nature's most dramatic examples of coevolution. What makes this battle even more fascinating is that Ophiocordyceps isn't just one species. There are dozens, each specialized to infect a specific insect. One fungus targets carpenter ants, another targets bullet ants. Others infect spiders, beetles, or caterpillars. The level of specificity is astonishing. A fungus that infects one species often cannot infect another. It has evolved to manipulate a single host in a highly tailored manner. This specialization raises one of the biggest questions in ecology. How does the fungus control behavior so precisely? Scientists used to think Ophiocordyceps invaded the brain directly, but when researchers scanned infected ants, they discovered something surprising. The fungus doesn't fully take over the brain. Instead, it leaves the brain mostly intact and spreads around the body, creating its own network that can override the host's nervous system. This means the fungus controls the insect not by replacing its brain, but by controlling the signals reaching it. It reroutes behavior like a hacker taking control of a machine. The insect becomes a biological puppet, and yet the fungus never stops growing. It consumes the insect until nothing is left except the exoskeleton and the fungal stalk emerging from it. This bizarre and horrifying life cycle has shaped entire rainforest ecosystems. Infected insects fall from trees, creating nutrient-rich patches on the forest floor. Spores influence the distribution of insect populations. Predator species respond to the availability of weakened or infected prey. Even plant growth is indirectly affected by how fungal infections change insect behavior. The zombie parasite war is not just a biological curiosity. It's a fundamental part of the rainforest's ecological balance. Ophiocordyceps is a reminder that nature is stranger, more brutal, and more ingenious than anything humans create in fiction. It's a parasite that turns life into a tool, behavior into a weapon, and hosts into stepping stones for its own survival. And the war continues. Insects evolve, the fungus adapts. Neither side wins, neither side escapes. They push each other into new evolutionary paths, shaping the future of entire ecosystems in the process. This is nature's zombie apocalypse, fought on a microscopic scale, hidden beneath the leaves, in a war as old as the forests themselves.